You know, the sine and cosine functions are extremely important when we're trying to understand waves, whether it's waves in the ocean or actually waves that we hear in the air in terms of sound waves. They all sort of exhibit a sort of up and down motion that's captured in the sine and the cosine. In fact, putting sine and cosine together, functions together in sort of complicated ways actually generate what we hear. Let's take a look at an example. So let's use a sine function to graph a sound wave with a period of 0.004 seconds and an amplitude of 5 centimeters. And then let's find the frequency in hertz for this sound wave. Okay, well, here we have it. You'll notice that the amplitude, so we're talking about the sine function, so the very famous sine function always starts at the origin and normally just goes up to 1 unit and then comes down, and the period is 2 pi. Here we want the amplitude to be 5. So you can see it's been stretched and exaggerated to have peaks at 5 and to have valleys at -5. And you can see that the period now also has been shrunken dramatically. So we have lots and lots and lots of period. We have a complete cycle, a complete period at 0.004. And you can see that exactly here. We've made one complete sinusoidal cycle in 0.004 units. And then another 0.004 units, we have another cycle. So there's the graph. And now the question is to find the frequency. And, well, what do I know? I know that the frequency is the reciprocal of the period. So to compute this, what we do is we say the frequency, I happen to know, is the reciprocal of the period. That's key, which in this case is the reciprocal of 0.004. And if you now actually work that out, we see 250 hertz. And so there we get information about sound waves by using the sine function.